Okay, so since we don't have class on Halloween, I want to walk you through the sample problem that we were going to do as a warm-up, and it's a review of doing confidence intervals for proportions that we had done last week in class. If you can handle this problem, then I would say you're in good shape, and the lab that you're going to have due for next week is really this type of problem. So if this video helps you, then you're in good shape to be able to do the lab as well. So here's the problem we were going to do as a warm-up. So as part of the packaging process, a random sample of 200 eggs is taken each day to make sure they are truly extra large before being placed into the packages. And in yesterday's check, 18 substandard eggs were found. So construct a 95% confidence interval, which gives us the true proportion of substandard eggs. And be sure to check the conditions for constructing the interval. So I'm going to walk you through this problem and how we do it. It's similar to the ones we did last week. And then I'm also going to show you at the end how you do this type of problem using the graphing calculator, and that part is brand new, so you'll want to pay attention to the end part. So in this problem, let's just summarize the information. We're told that there are 18 substandard eggs, and that we take a random sample of 200 total eggs, and we want a 95% confidence interval. So this is what we want to do. And before we dive into the formulas and whatnot, we want to make sure we check the conditions. And this is the part that a lot of people overlook. So there's really three conditions you have to check. Three things that have to be true about this problem before you're even able to do any mathematics. So the first thing is you have to check to make sure that you took a random sample. And the problem does tell us that the eggs were a random sample. They say that the eggs were taken randomly, so we're in good shape with that one. The second thing you have to make sure of is that we have a large population. It's that condition that we always kind of talk about but never really do, where the population has to be at least 10 times as large as the sample. If we're taking a sample of 200 eggs, that means are there more than 2,000 eggs a day at this place that's collecting the eggs? And we can assume that there's lots of eggs here. The part that's really mathematical and we have to worry about are these NP greater than equal to 10 and N1 minus P being greater than equal to 10 conditions. And those are nice little formulas, but really the way you should think about those is as number of successes and number of failures. So are the number of successes greater than 10? Well, the number of successes here are the number of substandard eggs, and we collected 18 of those, and that's greater than 10, so we're in good shape there. And the other formula is the number of failures. Well, if we collected 18 substandard eggs, it means that we collected 182 good eggs, and that's also greater than 10. So those two things are also met, and that's probably the most important condition and the one you have to check, the number of successes and failures. So now we're all set to do the math. We're actually going to make the interval now, and I want you to pay no heed to the stupid spelling error that now appears on your screen. But we're going to make the interval, and every confidence interval has the same exact structure. You take some estimate, and you add or subtract the margin of error. And last week we learned that can be done using this formula here. That's in section 9.2 of your book. So really this just becomes piecing together everything we know. Well, p hat is just the point estimate. What's the proportion of substandard eggs we had? That's 18 over 200, and that's 9%, 0.09. Plus or minus? Well, since we're doing a 95% confidence interval, that z is 1.96. If you want to use the number 2 because it's 2 standard deviations, that's fine too. I'll accept either one, and frankly, neither one will make a big deal in your calculation. And it's this last nasty piece we have to do. P hat is 0.09. 1 minus p hat is then 0.91, and n is 200. I put that in my calculator. I get 0.0202. So now we have to take 0.09 and add or subtract it from that stuff at the end, and I put that all in my calculator, and I find out that 95% confidence interval is from 0.0504 to 0.1296. So that means that we are 95% confident that the true proportion of eggs that will be substandard if we were to check all of the eggs in this place that collects eggs to be between 5% and 13%. We're 95% confident of that. So that was the work we did last week, and if you can handle that work, you're all set for lab number 2. But there's another way to do it, and that is you can use your graphing calculator. Your graphing calculator does confidence intervals quite nicely, so here's how you walk your way through it. So here's my calculator. I took it into my dining room and took a picture. The way you have to start is you're going to press the stat key. It's the same button we use to get to our lists. But usually we press stat edit. This time you're going to press the test button. You're going to go over to test rather. So stat and over to tests, and you're going to get this menu of stuff that you've never seen before or never really thought about before. And this is where we do confidence intervals, and down the road we're going to do hypothesis tests. And for the second half of this class, we're going to become very familiar with this test menu. Under the test menu, feel free to scroll through it, but the one you want, if you scroll down to letter A, is a 1 prop z interval. We have one proportion in this problem, and we're doing a z interval because we're using a normal distribution to do it. So it's a 1 prop z interval. You can kind of look at some of the others and get a preview of some of the other things we're going to do. If you click 1 prop z interval, you get this menu here. And for 1 prop z interval, it really doesn't ask you for a whole lot. This problem is about the number of substandard eggs, and that's a count, and that's going to be x. So the first thing you have to tell the calculator is x. How many substandard eggs were there? How many successes were there? Here there were 18 of those eggs. Next part is n. N is the total. There were 200 total eggs taken. And the last piece is the confidence level. We want a 95% confidence interval. You can change that to 99%, or you can change it to 90%. After we're done with this problem, you might want to recalculate it as a 99% or 90% and kind of watch how the confidence interval behaves. And then you're just going to go down and press calculate. And calculate will give you this, and it tells you what the confidence interval is. And it's pretty much the same one we calculated. It might be a little bit different because it didn't round off some of the things like we did when we did the calculations just by writing them down. And it also gives us p hat. So you're going to be responsible for being able to do this by formula, but you're also going to definitely want to be able to use this on the calculator and use the benefits of the calculator. So I hope this is helpful, and this should be able to get you through doing lab number 2.